Hello, everyone. Welcome. Welcome to our workshop. I'm here to talk about Chainlink and especially about the cross-chain protocol. So this is our goal. And thank you so much for the DappCon team for organizing this amazing event and to have me here. This is me. My name is Solange Gueiros. You can call me Sol. I am a developer advocate at Chainlink Labs, and I used to travel around the world to conferences to talk about Chainlink and to teach developers, and I really love to teach and to bring in new people to this Web3 ecosystem environment, and I really enjoy to teach. The last link is my website. I used to add my talks over there, so you can see other talks and workshops. And we are here. Let's go to this place first, before I talk anything. And here you can put like your name and where are you from? Like I'm Sol, from Brazil. And okay, let's add this here to help you. We are in this link now. And this is a collaborative pad. We can write together. We can delete everything, so be careful. But this is the best place to work together. And I used to say that if you know how to copy and paste, you can do my workshop. Because I will copy and paste all the code for you here, all the instructions, and you can do the same in your own computer. So welcome, Christopher. And let's wait a bit more for the others. And like I said before, I will talk about the CCAP. This is the cross-chain protocol communication by Chainlink. And when we talk about this, I used to do 3 or 4 approaches related to how can we do this. Like you can transfer tokens, we can transfer messages, and when we talk about messages, we can transfer commands and call functions. And this is our goal today, because my goal is to mint an NFT in one chain, and this NFT will appear in another chain. And I'm doing this only using Remix, so we have like a hard hat starter kit as well, but I'd like to do in the easy way, so we are not installing nothing on our computer. It's only using Remix, and we need to have some tokens. I think the hardest part is to get the tokens. My goal is starting on Avalanche Fuji and finishing on Ethereum Sepolia. So I will send commands on Fuji, a transaction on Fuji, and this is sent a transaction to Ethereum Sepolia, and our NFT will appear on Sepolia. Is this? Wow, we have Luke from IT. Where are you, Luke? Oh, nice one, Luke. And a lot of people from Germany as well, and Georgie from Spain. Oh, amazing. Welcome to all of you. And this is, let's come back to my presentation a bit more. And to understand a bit of the concepts, how can we update NFTs with blockchain oracles? First of all, remember that NFTs representing something can be a punk, a ticket, a real estate, apartment, or badges or trading cards. And but even today, the most part of the NFTs are static. And the goal and the feature of the NFTs are to be dynamic. In this case, I have an NFT from LaMelo, the basketball player that is updating using his scores. And when we talk about updating NFTs, you can define your own rules to do this. Can be scores, career highlights, weather experience, whatever. And my goal, I'm finishing a new workshop, and the idea is like when we to have the same NFT in two chains, and you can, for example, using the metadata to see where is active, where is not active, for example. For today, I'm only meeting the NFT in another chain, but the goal is to create a NFT that can live in different chains and be dynamic in this way as well. When we talk about oracles to update an NFT, it's important to know what's an oracle. An oracle is any device or external resource that you can use in your own smart contract, and you can talk about like temperature, weather, sports information, financial information. I have a lot. Even the information from my watch, I can use this as well. And this is Chainlink. When we talk about oracles, we are all important. Chainlink is not a blockchain. Chainlink, it's a set of services that are deployed in different blockchains. Like this, we have a network of nodes. We used to say a DON, decentralized oracle network, for different services. And we can have these services for data feeds. This is the most popular. But also, we have services to automate smart contract execution, to generate random numbers, to call external APIs that you can write code on JavaScript and use this information inside a smart contract. And this is some examples of dynamic NFTs that I did before in workshops, like to grow a flower, to have these characters that can run, can do something different. Today we are using these characters as well. This is our NFTs. And this is another that I did before. It's like SVG price feed. Imagine that if the price from one time to another is growing up, I'm happy, or if it's going down, I'm sad. And we have different background colors. And all of this is another dynamic NFT that I code everything inside the smart contract. So this is interesting. How can you update this? And this is our goal today, how to mint an NFT in one chain from another chain. And we are using the CCAP, Interoperability Protocol. And before talk about CCAP, let's start with the requirements. Because like I said before, this is the most difficult part. And I have here my requirements, and I will copy and paste here to you to be together. And we must have this. First of all, I told you that we are starting on Avalanche Fuji. So we need to add Fuji to MetaMask. If you go to chainlist.org, connect your wallet, and you can add it. I can't because I probably already have it. Yes, Avalanche Fuji is here. Okay. And the next step, you must have tokens on Avalanche Fuji. This is not good now. Probably we can go directly to the Chainlink faucet. And this is the same, you are connecting your wallet. And then here you can get the link token and the Fuji token. Here, I can get 20 link tokens and 0.5 Avalanche Fuji tokens. I need to do a login using Twitter. Okay, if you have any problems, I can send to you later, okay? Another point, when I'm doing a cross-chain transaction, imagine that I must pay fees in the destination chain. How can I pay this? I'm paying this in the Cersei blockchain. And I can pay using the native token. For example, if I am here in Fuji, I can pay using Fuji. I can also pay using Link, And in the future, you can pay using other tokens as well. For us, like to get Fuji is not so easy in this moment. So I'm using Link to pay the fees because it's easy to get the Link tokens now in testnet. And this is our goal. You must have Link token and AVAX Fuji. Got this. The other part, I don't know what is the chain say if you want to. Oh. Okay. And the link. And also you must have some Sepolia. This is most common, so I hope you have it, but if you don't have it, do you need tokens? If you need, you must tell me your name, which token, and address. And probably I will try to send you in a minute, okay? Let's come back to our presentation, and you are getting your tokens now. So come back here. When I talk about cross-chain interoperability protocol, what can I do? I can transfer tokens. This is the basic like a bridge, but we have a mechanism with a bit more security. You can send any message. I used to send like a hello world, hello Berlin message from one chain to another. But when I'm sending message, what about a message that is a command that is calling a function in the other chain? And we are using this today. And in this point, when I can send commands and functions to the other chain, I can program a token transfer, for example. And like this can unlock the feature of an internet of blockchains because you don't have limits in this way to interact between contracts. And this is a bit of the cross-chain stack, like wallets, applications, where can you use it. And also, one important point that I need to tell you is related to the workflow. And here, we have a risk management network. So we have two different networks of nodes. One network is really monitoring one chain, getting the transactions in the router and sending to another chain. And there are another set of nodes that are really monitoring this in a security perspective, okay? So we have both. In some moments, I come back here to talk about use cases, but between this, I need to wait some minutes to my transaction be confirmed, so we can talk about this later. Let's go to the practical part again. So Felix, in a few minutes, I will send token for you, okay? First of all, we are starting on the destination chain. And this will be Sepolia. So in Sepolia, I will do 2 points now. First, I will create an NFT collection, an NFT smart contract, and then I will create the destination smart contract, okay? So, like I said before, I have like my copy here to tell you. We are creating the Chainlink NFT. Oh, wow, we are on Remix. Okay, don't forget that we are on Remix now. Let's go to Remix. So this I will do in MetaMask. And now I'm going to Remix. And first of all, in Remix, remember to go to the icon 5, environment, and injected provider. Let's do this. Remix 1, 2, 3, 4, 5. Environment, change this to injected provider, MetaMask, to be sure that your remix is connected with your wallet and approve this. I also used to go to Solidity compiler and enable the auto-compile. It's faster to you to work in this way. Icon 4. Let's enable the auto-compile. Now we are going to icon 2, File Explorer, and create our file. So we are creating the Chainlink NFT.sol. And here we are. What I have here, you can copy the code between the begin and the end. Let's create it. Let's see if I have it here. Yes, I have it. So I will use mine now. And probably I will change the name of NFT. This is the Chainlink DappCon. So let's update this for you as well. Line, where is the constructor? Constructor. Oh, the last time that I did this was in Argentina. So we are on DappCon now. So is this is our NFT. And yes, you must trust in my code now. But probably I copied something that more than I needed. Let's go from here until here. And let's deploy the NFT. This is only the NFT. And if you are with me, please add here your name and your NFT address. Let's get mine. I think I am in the wrong network. Let's see. Yes, I told you to go to Sepolia, but I won't. I didn't. Let's go to Sepolia. And now I can deploy. And so this is the wrong. Yes, let's get this. And where is the people that need Felix? Let's send to you. I think this is good. And mouth. And Mohammed. And to be sure, how was to create my contract, how much I spent. Oh, it's good. So with this, you can create your contract. Now I have my Chainlink NFT. Oh, Jordi, congratulations that you are doing with me. And this is, so we have the NFT in the destination chain. Now, when we send the mint command to the destination chain, we must have a contract to receive this command and to mint the NFT. So this will be our destination minter. Before that, if you'd like to see your NFT, maybe we can see before. If I go to OpenSea, this is the Chainlink DappCon. I already minted one NFT in my collection during the deploy. And to understand better what's my NFT, I'm only using OpenZeppelin, the basic, to create an NFT. I have these 4 images, 4 characters that I showed you before. In the constructor, I define the name of our collection, and I mint the first NFT. And like I have 4 NFTs, and I'm alternating the characters one by one. This is the next character. You'll be like 1, 2, 3, 0, 1, 2, 3, 0. Okay. And this only this. I have here the safe mint, the mint function, and it's simple. Okay. And this is my NFT. This is my collection. Next step, let's create the destination minter. This is a contract that will receive the mint command. Okay. Let's get this for you. And the same, begin, end, and here is the code. And let's see if I have this done here. Destination minter, I have it. I will explain what I have here. So here I'm using the Chainlink CCAP. I'm importing the CCAP receiver. This is importing the structures to the router, because the process is we have a router in the Cersei blockchain that receives our transaction. We have another router in the destination blockchain that is receiving the transaction from the Cersei blockchain and following to our contract. So we must have the CCAP receiver. Also, we have the client library with all the structures that we need. And I have the NFT. So here, when we have the router, we must, in each chain, the router has an address. How can I say this? How can I discover this? Because I locked this in my contract. But when we need to get the routers, you go to the supported networks. And for example, here is Sepolia, here is the router. Let's add the support networks for you if you need it. Okay, oh, here. And here we are. In the constructor, I'm initializing the NFT with the address of the NFT collection that I just created. And I must have a function with this name, underscore CCAP receive, because the router is looking for this function in my contract. When he found this function, he's sending the message to my contract. And what can be the message? In my case, the message is a comment. So I'm using the message with the address of my NFT. I'm calling the message, the information. It means that I'm using the mint function here. I will send the mint function from the other chain. Is this? And I create a test mint only to be sure that this is okay. I think I didn't create yet, so let's deploy the destination minter. I need to get the address of my NFT, add here in the parameter of the destination minter, and deploy. Confirm. And if you are with me, could you add here your name and destination minter address? Maybe I can try to interact with you later. Is this? This is mine. At least mine I will add for you, and you can use mine as well if you like it. So this is done. The destination part is good. Let's go to the Cersei part now. Cersei blockchain, UB Avalanche Fuji. So you must select this on MetaMask. Let's go. And this is the Cersei minter. Okay, I will add this for you. So now you must create the sourceminter.sol. Let's put this here. Here we are. Remember that you must go to Avalanche now. I am on Avalanche. Okay. Sourceminter, I have it here. And here you can see that also I'm importing in the source blockchain, the source contract. I'm importing an interface to the router, is this. The client of the CCIP as well. And because I'm paying using link, I must have the link token interface. I'm managing some parts here, like to see if I have enough link to pay the transaction, if I, at the end, would like to withdraw the tokens that I added, in this case, the link token. So I'm managing this. I will define the source router, the link token. Because I'm sending to another chain, I must know the code of the destination chain. I can get all of this here in the documentation. The chain selector is here, for example. And is this the destination minter? It's my contract that I already deployed on Sepolia. In the code structure, I created this in a way that only the owner can send this message, but you can do to any person do this. Here is the router in Fuji. For example, let's see here. If I go to Fuji, here is the router address that I'm using. It's here. And the link token as well. I got in the same place, link token. And the destination chain selector, it's Sepolia. So I'm minting on Sepolia. I'm creating a structure that is a message, EVM to any chain message. I must say what is the receiver, what's the address of the receiver in the other chain. What's my message? In this case, my message is the command, the function mint to the address. If I'm sending token, here I can define the token amounts. And in my case, I'm increasing the gas limit to be sure that I don't have problems in the destination chain. Here you can see that, okay, I am on Fuji now. I must know what is the fees in Sepolia? And this is like the hardest part. Sometimes I already got errors live because I send the transaction and the fee increased in that moment. What I sent, it was not enough. In this case, you can manually execute the transaction in the blockchain, destination blockchain. I can say you later. But you must be careful because now we can get fees, but this can change during the process, okay? And this is, we are sending a message to the destination chain, and the message is the mint command. Here I have the link balance, and to withdraw the link, it's only the owner that can get the link back, is this. Let's deploy this now. I must use the destination minter address here. Copy. Confirm. And could you add your name and source minter address? You are not with me. I'm sad. If you are doing. So let's get mine. Source minter, here we are. This is my address. Okay, next step. Hey, Mount, thank you, you are with me. And now I must fund the source-minter. Remember that we are using the link token, so I must send the link to my contract. I can do this on MetaMask. I will send 10 links to my contract. Let's go to MetaMask. If you don't have the link token appear here, let's solve this. Maybe you don't have it. Hey, Jordi is doing as well. How can I add the link token? Go. Link token contracts. It's a bit slow now. And I am on Fuji. You have the Add to Wallet button here, okay? If you need it. Let's see if I have it. And get my address again. Here I have it. Send. 10 links. Oh, congrats, George and Felix, that are doing with me. And here we are. Let's see if I have the tokens here now. Yes. So everything is done. I can mint on Sepolia now. And the important part now is to have your transaction ID. Let's do it. Remix source-minter, mint on Sepolia. Confirm. And I will get my transaction ID. Copy transaction ID. And I will use my transaction ID in the CCIP Explorer. Let's search my transaction ID here. And you can see that the search was finalized. But when we talk about blockchains, we must have the finality status in the transaction. It means that we must wait more blocks to be sure that cannot have a reorg in the chain anymore, and to be sure that your transaction cannot be reverted. Because of this, we used to wait more blocks, more time. And this is the case now. We must wait some minutes to do this. And I'm used to start on Fuji because from Fuji to Sepolia, I used to wait like 4 minutes. But if I start on Sepolia to Fuji, it's 20 minutes. So exactly because the time block is different. In this case, we are waiting. It's committed now. You just saw that change the status. I still must wait. But while I'm waiting, let's talk a bit more. Use cases. Some ideas to you related to CCIP. Cross-chain collateral. Imagine that you can have collateral in one chain and do using lend, borrow, whatever in another chain. And you are locking one chain using another chain. Another point, imagine that sometimes it's so expensive to do computation, simply computation. What about to do this computation in a low-cost chain and only bring the result to your main contract in another chain? You can also have yield optimization. You can have some profit between chains. And thinking about this, you can have different kind of applications, like I'm using NFTs, and you can have whatever you like. Imagine including a DAO that must vote. And a lot of times I saw DAOs deploying the structure in another cheaper blockchain. They started on Ethereum, and then it was so expensive to vote something on Ethereum. And let's do it in Gnosis, for example. Imagine that you can do this using a cross-chain application. And, I have one more that I'd like to show you. This is the basic architecture and workflow that we are doing. We are the user. We deployed the sender contract, and here we define what is the message and where is going, destination blockchain. Here we have the router that's receiving this, and outside we have the DON, the decentralized Oracle network, that's monitoring this and send the transaction to the router in the destination blockchain. And I am in the destination blockchain, so I don't have the destination chain anymore, but I have the message to send to my receiver contract. In our case, I must have the CCAP receive function, like I said before, the underscore CCAP receive. But if I'm sending tokens, for example, I can send it directly to my wallet, and I don't need to have this part. And this is a CCAP message can be only arbitrary messaging, or a command, or a token transfer. This is a bit complex structure, so when we talking especially about tokens, we used to have some mechanism in the token part. If you are the owner or the manager of the token, you can decide, for example, that you'd like to burn the token on chain and mint in another chain. But when we are not, Chainlink is managing some tokens. We have some test tokens now, and we can lock the token in the first chain, and in the second chain unlock or mint in the second chain. So you have the main token and almost a wrapped from that token in another chain. And you can manage this as well. And so important that, like I said before, we have another network of nodes that is monitoring all transactions to be sure that we don't have hacks, how we have a lot this year in bridges. This can be good for you before I come back. Like I said before, I have this in a hard hat package as well. So if you like to build more complex stuff, it's better to use hard hat than Remix. And this is another important QR code for you. This is the presentation. So all the links are here. And probably when I come back to the CCAP Explorer, my transaction is done. Let's see. One more minute. Okay. So let's see what's happened. Success. Yes. Well, it's success. So if I come back to my NFT collection, I should have 2 NFTs here now. Yes, I have 2. One was minted from Fuji. So do you have any question related to CCAP, or do you need tokens? Do you need help? Wait a minute. We have a mic because we have people online.
Hi. Can you elaborate on the risk management part?
Yes. There are another set of nodes that these nodes cannot commit transactions. They cannot see. They are monitoring this. So let's come back to my presentation because I have this in a detailed architecture and workflow. Here we are. When I have the router is sending tokens, something like that, the risk management network is writing in a smart contract. This is like another contract that's committing the transaction. So I can right here, and this contract is monitoring all the transactions here as well, using events to help this. In this way, before the transaction go from the source blockchain and be in the destination blockchain, this network is also monitoring the amount of blocks that we need to wait, and monitoring and be sure that the transaction will not be here before that. And also we have a structure that we are committing and saving the transactions in a smart contract that you can see where is this. So all of these are transactions on blockchain, and this is transparent, and you can see what's happened to be sure that we don't have, anyone cannot manipulate this. Okay? Also, if you need more information related to this, you can go to the resources, and not the resources anymore. You can go to the architecture and billing and concepts of this, okay? And let's see, Mount, what is your transaction? Let's see. What's happened with your, oh, probably what I did wrong. No, I add his name together. Okay. Mount is done as well. Yes, so good. And to finalize, also next week, if you are from Berlin, we have another boot camp. Like it will be 2 days, Monday and Tuesday, 4 hours per day, where I will teach you how to use all the Chainlink services. So if you are around here, you are welcome. And are you starting from zero? In this bootcamp, I will create ERC20 tokens, NFTs, and a token shop, and automated contracts, and create a raffle. I really create a lot of things.
Is that available remotely as well?
Only in person. For the remote people, you can check our website as well, or even my website, I have more online. And these are my contacts again. Feel free to contact me, and I hope to see you around the conference. And thank you so much. Also, if you need to talk more, I have Joy over there, Joy. She's a community manager from Chainlink as well. She lives in Berlin, so feel free to talk with her as well, and we are here to help you. Thank you.